Okay, so the first case is we have an exponential equal to an exponential. And this can come in a couple of different flavors. The exponentials can have the same base, they can have bases that are related, or they can have completely different bases that have no connection. We're going to look at all three cases. So first, we're going to look at same base problems. Whoops. So if the two exponentials have the same base, 2 to the a equals 2 to the b. If those two expressions are equal, what do I know about their exponents? Louder, Ethan. They're also equal, yeah. Those expressions are equal and their bases are equal. Their exponents should probably also be equal. So in cases where the bases match, 2 to the a equals 2 to the b, the exponents are just equal. We don't even have to do any extra algebra. So let's take a look at some examples. Come on. Cooperate today. So 2 to the x minus 1 equals 2 to the 2x minus 4. I can't isolate the exponentials because there's more than one. I have an exponential equal to an exponential. I recognize that the bases are equal, which means the exponents should also be equal. So 2 to the something equals 2 to the something. Those somethings must be the same. This is now a Math 1 question. Yes, Bruno?
Then couldn't we make it so like make x have it so whatever minus 1 and minus 4 be 0?
No. No. You're right that 2 to the 0 equals 2 to the 0, but that's not the question we're answering. Yeah. So there is another option here, which is they equal each other. In order to solve these questions, I need variables on one side, numbers on the other. And my instinct is to move the variables to the side that has the bigger coefficient. So I'm going to move the 1x over here. And we are in pre-calculus, meaning we can do two steps at once. I know that I want to move variables to the right, minus, come on, pen, minus x, minus x. I want to move numbers to the left, plus 4, plus 4. Here, the x's cancel. Here, the 4's cancel. So now I have numbers on the left and variables on the right. Two things at once. On the left, negative 1 plus 4 is 3. 2x minus x is x. So x equals 3 is a solution to that equation. And we should check that it makes sense. If we plug x equals 3 in, what is 3 minus 1? 2. So this is 2 squared, which is 4. On this side, 2 times 3 is 6. 6 minus 4 is 2, which is 2 squared, which is 4. So this checks out. X equals 3 is my answer. Howdy face. Yeah, we can do this. We can do this. All right, next one. Three to the x minus 5 equals 3 to the 6x plus 2. Matches the exponential equals an exponential form. And the bases of those exponentials are the same. Alan, what does that tell us? The bases are the same. What else do we know? Exponents are the same. Yeah. So x minus 5 must be the same as 6x plus 2. That is a 6. It's a messy 6. I'm sorry. It's been a long day. Same process. X's to one side, numbers to the other. I want to move my x's to the right, to the side with the bigger coefficient. So I'm going to subtract x from both sides. I want to move the numbers to the left. What should I do? Minus 2. Very good. Minus 2. Minus 2. So on this side, those cancel. This side, those cancel. I get minus 7. Please turn that off. Equals 5x. I think I did that correctly. I see nodding. Good. Last step. Lucero, what should I do last to solve for x? So I have negative 7 equals 5x. What should I do to get x by itself? So focus on the side with the variable. What's the operation between the 5 and the x? Got two numbers. Yeah, it's multiplications. We need to divide. Good. Yeah. Good. No, it's okay. 5's cancel. X equals negative 7 over 5. Happy face. Yeah. Good. Good. I'm tired of looking. I'm just going to look it up in the book. All right. So same base. Not too bad. Bases are equal. Exponents are equal. A little bit of math 1 algebra to solve for x. Next question is what happens when the bases are related but not the same? Bases are related. Bases are related. So, for example, two x plus 3 equals 4x minus 5. They are related, meaning I can write 2 and 4 as exponentials with the same base. So the strategy when those bases are related is rewrite with same base. In this case, I want to use base 2. Don't have to touch the left. 4 is a power of 2. 4 is 2 to the what? Second, 2 squared. So 2x plus 3 equals 2 squared to the x minus 5. I'm just rewriting 4 as a power of 2. They have a common base. Then we're going to use properties of exponents. This is a power of a power. Exponent of an exponent. When I have a power of a power, what do I do with those exponents? Multiply. Yeah. So we're going to do 2 times x minus 5. And remember that when you multiply, you have to distribute. So the 2 goes both to the x and the minus 5. So 2x minus 10 This hopefully looks familiar. Now that they have the same base, what do I know about their exponents? They are equal. Very good. X plus 3 equals 2x minus 10. I'm going to move the x's to the right and the numbers to the left. So minus x minus x. I want to move the numbers the other direction. So plus 10 plus 10. 10s cancel. X's cancel. And what am I left with? On the left, 3 plus 10 is 13. On the right, 2x minus x is 1x. Put the phone away. Brownie face. Brownie face. All right, try another one. Slightly trickier. Eight to the x plus 2 equals 16 to the x plus 1. $16 is not a power of 8. 8 times 8 is 64. But both 8 and 16 are powers of another number. I know 8 is 2 to the third from the last question. What about 16? 16 is 2 to the what? 4. I need another 2 to turn 8 into 16. Yeah. I can rewrite both of these as powers of 2. So 2 cubed to the x plus 2 equals 2 to the 4th to the x plus 1. Rewriting with a common base, because those bases were related. I could see they were related. What do I do next? Very good. Multiply the exponents, power of power. So we get 2 to the 3x plus 6 equals 2 to the 4x plus 4. We multiply a binomial by a number. I have to distribute to both terms in the binomial. Good. Jordan, what's next? Very good. So 3x plus 6 equals 4x plus. My pen is trying me today. I swear you guys all wait till I start lessons. All right, Melanie, what's next? Draw the lines between the equals. Gotta get a thumbs up if we agree. Very good. Perfect. Perfect. You should. I happen to set up the problem, so I know that they work. And when you're doing Delta Math will check for you. Good. Good. Okay. Now, what happens when those bases are not related? What was that suggestion, Gerardo? No, I'm curious. What did you say? For sure? Okay. So these are exponentials. We know exponentials are undone by logs. That principle still works here, but the problem is I don't have a common base because different bases. So we're going to pick a log that's easy to evaluate on our calculator since I don't have a common base to use. So I would suggest log base 10 or ln. You're going to see me use ln or natural log because that's more common in science. And pre-cal is used a lot in science. So my suggestion is take the natural log of both sides. And we're going to do some examples. Before I do them, I'm going to warn you that at some point during this process, it is going to look ugly because we're going to have natural log of a number, natural log of a number, natural log of a number. Those are just numbers. They behave just like whole numbers do, 2, 4, 10, right? They look gross. They are just numbers that go in a calculator. Yeah? Okay, so let's try one. Five to the x plus 2 equals 4 to the x. I want to know what value of x makes that statement true. I cannot write 4 in terms of 5 or 5 in terms of 4. 4 is a power of 2. 5 is prime. Not related. So we're going to take natural log of both sides. Yeah? So natural log of 5x plus 2 equals natural log of 4 to the x. Yeah, literally just taking natural log of both sides. We're going to simplify using properties of logs. Yeah, I'm going to need to use the properties of logs to get x out of the exponent and do the math. So first, if I have an exponent inside a log, I know I can pull it out in front as a coefficient. Those logs pick off exponents. So this x plus 2 is going to come down in front. And over here, the x is going to come down in front. Which has solved the problem with the variables in the exponent and turned it into a linear equation. X times some numbers. We can deal with this. Keep in mind, ln of 5 is a number in my calculator. ln of 4 is a number in my calculator. It's gross, but it's just a number. So I have x plus 2 times something. I want to get rid of those parentheses. What should I do? Starts with a D. Distribute. Yeah, I should multiply that number through the parentheses. So I need to separate the x and the 2. So I'm going to get x times ln of 5 plus 2 times ln of 5. We're getting closer. I'm at the stage where I was in the last couple examples where I want the x's on one side and the numbers on the other. And we're going to approach it the same way that we did in the last couple examples. Subtract the x with the smaller coefficient from both sides. Add or subtract the numbers from both sides, yeah? So I have ln of 5 and ln of 4. Which one of those is smaller? Ln of 4. So I'm going to subtract x times ln of 4 from both sides, so that those guys cancel. What? So my x's are now all on the left, which means I want the constants, the numbers, on the right. I need to move this guy. Looks gross. Same step we've been using in the last 4 examples. X is in one direction, numbers in the other. All of those ln's are just numbers. So let's write out what's left. Yeah? Over here, I've got x natural log of 5 minus x natural log of 4. On the other side, I have a negative 2 natural log of 5. I want to get x by itself, so I'm going to factor the x that's in common from both of these terms out in front. When we're dealing with those previous examples, that happened naturally, because I can do 5x minus 4x. I can't do that neatly with ln 5, ln 4. I have x times a number equals a number. Looks gross, but that's all it is. X times a number equals a number. I could just divide by the thing that's times the x and call it a day. I'm going to show you how to make it prettier using some log properties, because we are in pre-cal and that's what we should do. On the left, subtraction outside of a log becomes what inside of the log? Subtraction connects to what? Division, yeah. So this is just ln of 5 divided by 4. On the other side, constants out in front become what inside? Exponents. So this is actually natural log of 5 to the negative 2. Negative exponents tell us to do what? Fraction. Very good. So this is 1 over 5 squared. What is 5 squared? 25. So this is just natural log of 1/25. Slightly less scary. I have x times the number. I want to get x by itself. How do I undo the multiplication? Divide. And I divide by the constant next to the x, which is ln of 5 over 4. That's why we baby step, right? That's why we learn linear equations first and then quadratics, and we baby step our way up. So x is just natural log of 1 over 25 divided by natural log of 5 over 4. Those are things we can plug in a calculator. There is an ln button on our calculator. I would encourage you to do that now. What is ln of 1 over 25 divided by ln of 5/4? I got negative 14.425 something, something, something. Be careful with your placement of parentheses. I know that should be accurate because I know that ln of a number that's less than 1 is going to be negative. It's dropped beneath the axis. I know that this is going to be bigger than 1 because I know ln of 1 is 0. The log of 1 is 0 because the point 1 comma 0 is on our graph. This is smaller than 1, it's negative. This is bigger than 1, it's positive. Negative divided by positive is negative. So that makes sense that I have a negative answer. Okay. Try another one because it's good for us. There should be an ln button on your calculator next to the 4, like in between the 4. Good. You got what, huh? Oh. All right, so we want to solve 2 to the x equals 3 to the x plus 1 for x. Yeah, no, we're doing lots of math. Yeah, that's welcome to college. All right. Marissa, first step. Natural log. Good. Bases are different. Bases are not connected. Just take a natural log of both sides. Good. Gabe, next step. Very good. Exponents come down in front. ln of 2 equals x plus 1 ln of 3. Jackie, next step. Was the same third step as the last example. I want to get rid of those parentheses. Starts with a D. Distribute. Yeah. Multiply that constant, ln3, through the parentheses. We need to separate the x's from the numbers. Julie, suggestion. What's next? What would you do? I want to get all the x's on the same side of the equation. What should I do? Subtract. What am I subtracting? That's probably the easiest way to do it. Since I already have an x by itself over here, just move this over here. We don't have to. That's a good pattern. I prefer to do that if I have 2 terms on each side. In this case, because x was already by itself on the left, it made more sense to move all the other x's with it. So then I don't have to move constants. It's 1 instead of 2. Otherwise, I would have had to move 2 pieces. And I'm lazy. So it's not wrong, but I'm trying to do it in as few steps as possible because, again, lazy. And the question is, what does that leave us with? Those cancel. I'm going to factor my x out now because I know it's coming. Both of these terms have an x. ln of 2 minus ln of 3. I'm going to simplify before I divide. I know division's coming because it's x times the number. I'm going to make that number a little prettier. Subtraction outside a log becomes division inside the log. So 2/3. Who can tell me my last step? Aubrey, last step. How do I undo that? Divide. Divide by the constant next to the x. So I can see on the left, constant cancels. We get x equals ln of 3 over ln of 2/3. And we're going to grab our calculator and check that. Before we run it on the calculator, am I expecting a positive answer or a negative answer? Ooh. 3 is bigger than 1. ln of 3 should be positive. 2/3 is less than 1, positive or negative. So remember that our log graph looks like this. And that point there is 1, 0. So any x value that's less than 1 is going to have a negative y. So positive divided by negative should be I'm getting 2.7. Yeah. That's 2.7. 2.7. We do. We have one quick one that's not going to take very long at all. Without any calculations, what is the solution to that equation? 2 to the 1 is 2, 3 to the 1 is 3, 2 does not equal 3. What is 2 to the 0? 1. What is 3 to the 0? 1. So x equals 0 is the only solution to that equation. Yeah. Good. The exponential answer is 1. The solution to the variable that makes that statement true, is 0. All right, when I see you on Thursday, we're going to do some, I think, 1 or 2 more complicated examples. So you have like worst case scenario. We'll do some small group practice. Don't forget delta math, due on Monday. 5 exponential, 5 log, practice solving.